Just one more moment. All right. I hope you can see my screen now.
It's coming up. Yep, we can see.
So in the last class, we talked about how the RAG works, right? Retrieval augmented generation, and why do we need it? Okay. Maybe if, all right. So in the RAG, what happens? I mean, we talked about why do we need RAG at the first place. The most common reason is since all the large language models are not trained on our private data, which is private to our own companies and organizations. So what we can do is we can create some knowledge base, some vector databases, and we can put our private data into those vector databases. And then once the user asks any question, first of all, a search will happen on our vector database. That search will pull the relevant context. And then along with my question, that context will be sent to the LLM so that it can produce the answer. For example, if we have some policies of a company, let's say its promotion policy, or maybe its onboarding documents, okay, how to raise the triggers and things like that, what we can do is we can take all these policies, the PDFs, different documents, and we can vectorize it and put it in a vector database like Chroma database, Pinecone, FAISS, FAS, VV8. So there are a lot of vector databases. We can use those databases to store the embeddings, okay, of these documents. And then once the user asks a question, for example, my question is, uh, how many leaves are there in Birlasoft? Now, OpenAI cannot answer this question because that may not have been trained on the data of a company like Birlasoft or Infosys. Since I have taken my policies, leave policies and everything and put it in a vector database, now if I ask a question, first it will go to my vector database. My question is how many days I will get sick leaves. Then it will search in the entire vector database. Is there any chunk or piece of text which is very similar to the question the user has asked? If it is able to find, it will take those chunks and along with the question, it will be sent to my LLM. Now the LLM is having the user question plus some relevant chunk. Earlier it was not having that text, right? Because that text is private to the company. Now it is having access to that context. Now it can answer, okay, Birlasoft is having a policy of 10 sick leaves in a year. Okay, so like that, we can create and build applications on top of our own data. So that is one of the most useful test cases. And we also built one onboarding application. Okay, we created the user interface as well with the help of Streamlit, right? But that PDF file and the content on which we created that application was very simple. Very simple in the sense we just used very clean PDF file. Okay, so that was having only and only text. But if you use same application and if you use some complicated PDF, let's say the PDF which is having some diagrams and some tables and some images and some formulas, in that case, the simple RAG approach will not work. Okay, so that's why today we are going to study if we are having such content which is complex. Complex in the sense it is a multimodal content. It can be images, the documents may have diagrams, images, formulas, and things like that. Then what we can do is we can use multimodal RAG approach. This is also called as the advanced RAG. So now we will see today how we can deal with such kind of data. Okay, so you can see in the last module we
So
ingested.
Surinder,
Yeah,
I haven't seen the recording for that one. I think I saw the YouTube link, but I didn't see the recording for RAG one. I might have missed that one. Do you mind to send it again?
yeah, sure,
I
sure.
saw
I
the
will send.
Streamlit one, I but didn't see the RAG one.
Mm-hmm. Syed Raghavendra Ankur, can you guys confirm? Uh,
No, even I don't see that.
okay.
Surendra, I have seen your RAG session from the previous videos, not from this session videos.
Batch one. Okay.
Yes.
Yeah, that's what I say. YouTube had a your earlier recording, but what you were
Mhm.
talked about the first touch of the RAG. I didn't see the recording. Yeah, that's
Let.
fine.
um okay, I will check it again. Okay. So that is multimodal RAG. So last module we ingested PDF documents that were abnormally clean. In the real world, you will rarely find any such documents which are very clean. Clean in the sense there is just a text. Okay. Delving deeper into the ETL side of the RAG pipeline, the PDF has tables, images, scanned pages, plots, and etc. So we will be dealing with such documents which are a bit complex. For example, so this is the unstructured ETL pipeline. Okay. In the last class also we saw, if even if we have a PDF which is very simple, what we do is we extract the text with the help of certain loaders, which are like LangChain loaders. I mean, you can use. Once you extract the text, then it will be very easy to deal with. Okay, so we have to work hard on this ETL pipeline now, because now our documents are very complex. It has images and things like that. So the main complexity is in this portion of the entire pipeline. How to extract that information from these documents. Okay, so that is the main challenge. We can have Word document, we can have HTML document or a PDF. So the main challenge is how to extract information out of that complex document. Okay. Rest of the things are going to be same. Let me show you. So this is end-to-end pipeline. Okay. So what we are going to do is, all right. So this is the ETL pipeline, which we just talked about. These are unstructured data. These are different loaders. Okay, these are document loaders. We will extract text out of it, and then we will create chunks. Okay, chunk one, chunk two, chunk three, and then we create embeddings out of it. Embeddings are what? It is nothing but the vector representation or mathematical representation of your piece of text. Okay, so all these chunks which we have created out of these text elements, they all get converted into some vectors, and then they are stored in a special database which is called as a vector database. Okay, so everyone will be stored in form of a vector, and all those vectors or which are similar in meaning, all those chunks. Okay, let's say this chunk is talking about Shri Ram, Ayodhya, Sita. Okay, this is talking about something else. Let's say the movies of the Amitabh Bachchan, and this is talking about the movies of Dharmendra. So these two chunks will be close enough, okay, in the vector database. And the chunks which are talking about maybe Ramayana, those will be closer to each other. Ram, temple, and all those things, Ayodhya, right? Because they are semantically similar. Okay, so this is the purpose of this vector database. Now, what will happen once the user asks a question, that question is again converted into one vector. Okay, and then that question or that vector is searched across this vector database to pull the most similar results. Okay, so when we say it is having some information of Ram, this is having some Sita, this is, so if I ask a question like who is Hanuman or when is Hanuman Jayanti celebrated, what will happen? It will bring out the most similar context. Okay, so the Hanuman, Sita, Ram, all these vectors will be very close enough. So this in vector database, what happens? Similarity search happens. And for example, if you have a vector, okay, so it will find the cos theta between those two vectors, cosine similarity. Okay, the closer the vectors, more near it is to the value 1. Cos 0 is what? 1. If they are 100% identical, then those sentences are exactly same. Okay, so once I get those vectors or embeddings, those chunks will be passed to my LLM along with my question. Okay, now this large language model is having access to the relevant context, and then it can answer the user's question. Earlier, what was happening, if we remove this entire pipeline, if I directly ask this question, this LLM will not be able to answer because it is not having any knowledge about maybe Ramayana or maybe my company's policy about leaves. Okay, so this is the RAG pipeline which we discussed in the last lecture. In this chapter, which is on the advanced RAG, we need to deal more into this ETL pipeline, how to extract the text out of it. Okay. So in case of multimodal and advanced RAG are almost same. Okay, multimodal in the sense not only our question is in the form of text, but it can be images, videos, audios. Okay, so multimodal, different modes, basically different modular data. So there are three approaches which we can use to deal with such multimodal data. First is multimodal embedding of all the elements. So what we can do, the model will be able to vectorize text, images, and any other data type that it has been trained on into a single vector space. Okay. So what we are talking about is that we will have a vector database. So vector database is what? Or embedding model is what? Embedding model is again a machine learning model only. Okay, which is being trained on some data. And then it is trained in such a way that it can create embeddings out of the given text or images. If our embedding model is trained only to vectorize the text, then it can only create embeddings of the text data. If it is being trained to create embeddings of the images as well, okay, then what it can do, if you give an image in an input, it will create the vector or embedding of that image as well. So what does that mean? If I have a sentence like the vectorized image of the Lord Ram might be positioned close to a text talking about the Ayodhya. Does that make sense, everyone? So what I'm saying
Yes.
is, if this is my uh, embedding or the vector space, what will happen is, if my input is text, what will happen? One vector will be created. Okay, because my embedding model is trained on text as well as on image. And if my input is image, then also my embedding model will be creating one vector with the help of that image. Okay, it will see that image. Okay, the image is from, let's say, Lord Ram. It will be able to understand that image and it will convert that image into some text and internally will create one vector which is very much similar to any text which was talking about Ayodhya, Ram or Ramayana. Okay, this is the angle theta. Is that clear?
So, Surendra, do we need to
Hmm.
train that vector database?
No. Sorry, not vector database. We need to, we are talking about embedding model. Okay, so embedding model creates the embedding and then we store in the vector database. Okay, vector database is just used to store those numerical values, right?
Yeah,
One
no, for
comma.
example,
Hmm.
like you said, right? If I have an image of cat, for
Hmm.
example, right?
Hmm.
And I like to store as a vector date as a vector form, right?
Hmm. Hmm.
Is it something we need to create it, or these are the LLM model itself gonna give me these are the cat images converted into the vector
Hmm.
form?
Got
How
it. Yeah.
does yeah.
So it happens with the help of these embedding models. So they are already created. Different companies have created their own models. Some embedding models are text based. They can only create embeddings when you give some text to it. Okay. And there are some embedding models which are trained on text and image as well. So we will just use those images. We will import their libraries. For example, Clip is such a model. This is also from OpenAI. So if I need to deal with such a data which is having text as well as images, what I will do is I will just use the Clip embedding model, and I will give these images as an input, and it will automatically create those vectors out of it.
Okay.
So for me, it's just like, I have just switched from embeddings, OpenAI, embedding models like, text, ADA, or large. Instead of those, I will be using Clip model this time because my input data is multimodal.
Okay, so we need to run the 2 LLM part of it. One thing to convert into that vector database
Mhm.
using this library, and once we have that one, then finally the LLM which gonna give me this user response back.
Correct, correct.
Okay.
Okay. So these LLMs which are creating embeddings are basically called embedding models. Okay, let me take you to this website.
So, so in the
Yeah.
in last session, as we seen, like similar meaning of chunks will create their own colony nearby. It will store in the vector database nearby to the next
Hmm.
chunk, right? So
Exactly.
in this example, as you shown in multimodal,
Hmm.
uh, the chunk of image will be stored nearby to that text, right?
Exactly.
Mm-hmm.
Okay, so it make no difference once it has entered into the vector database. Okay, so these are the models. For example, these are the reasoning models. Okay, so from OpenAI, they have like O1. All the O series models are reasoning models. O1, O3 mini, O1 mini, O1 Pro. This O1 is highly intelligent reasoning model, and these mini ones are basically are cost effective. Okay, they are fast and they are cost effective, but they are not as efficient as O1. Okay, so O3 mini, O1 mini, these are fast and efficient, but they are reasoning models. And then you have GPT 4.5, 4.0, Chat GPT 4.0, 4.0 audio. This is for audio. GPT 4.0 mini. This is again most reasonable, fast, affordable. Okay, GPT 4.0 mini audio. Okay, I am searching. This is Whisper, which can convert your audio to text. These are the embedding models I was talking about. Is text embedding 3 small, text embedding ADA. This is one of the oldest model. And today, as of today, if I need to build any application and I need to use OpenAI embedding models, I will be using one out of these two. But these are text models. Okay, I cannot send an image to create embeddings out of it. For that, I need to use some models which are multimodal. Let me search Clip.
So, Surendra, similarly, we are
Hmm.
having Hugging Face embedding models
Yes, yes,
for
yes,
same. Okay.
yes. Clip connecting text and images. Okay, so we can use this model basically. Okay, so what this model will do? If you give an image, it will analyze that image. Let's say if you give an image of banana, it will analyze, okay, this is a banana, and then it will create an embedding which is very much similar to the text banana. Okay, and it will place in the uh, vector space. Okay, I think this is clear now. Let's go. So this is one of my approach. Okay, if I have a multimodal uh, data, what I can do is I can use or create multimodal embeddings. Second is depending on the document, converting entire page into images and passing them to multimodal LLMs. Sometimes you will have to try a more brute force approach. In those cases, you may have to treat entire page of a given document as an image. This image might be particularly useful when you have entire pages that covers a single topic. Okay, let's say you have a book which is having 100 pages with 100 stories. That means each page in itself is a chapter, or it's an individual entity, and each page is having some text and some images. So what I can do is I can give this 100-page PDF into these multimodal LLMs so that they can treat every single page as one document, and they will analyze that particular document. Okay, this might be pretty useful when you have entire pages that cover a single topic, like big tables that might make it harder to partitioning models to extract the text from them. Then you would combine this method with the previous method to summarize it and vectorize it. Okay, so once you get the content out of your LLM, what you can do is you can use that content again to put it into some vector database. Okay. And the third approach, which we will do today, we will see in detail. What is that? Summarizing multimodal elements, extract and summarize each multimodal elements. In this approach, what we are going to do, this method involves extracting every element of your document. So let's say I have a PDF that is having multiple tables, multiple images, and lot of text, and tagging them with a summary. You then link the summary to the original document, and you vectorize the summary using a text embedding model. Okay, so I think this will be more clear once I show you this diagram. In the third approach, let's say
So
this is a,
Surender,
yeah.
if I take a picture of my email and upload in ChatGPT, does
Mhm.
it go through the embedding one or does it goes as a text one?
That is directly going to your model, and it is getting converted into your text. Okay, so there is no embedding model. Embedding model is required only when you are going with the RAG approach. Okay,
Okay.
so let me just go through this diagram. I think a lot of things will be clear. Okay. So we are talking about RAG. That means what we want to do is we are not directly dealing with the model. Okay. Let's say if I have a knowledge base, I have a lot of policies, maybe some catalogs. Okay. Let's say I am working at a Tata Motors, and I have a lot of catalogs with the different models of a car, Nexon, Creative, Nexon Plus, blah, blah, blah. I want to vectorize, and I want to build a system which can basically put all these catalogs into my vector database. And if I ask any question on top of it, it should be able to pull the relevant information. Okay. So for example, if let's say this is a catalog, or this is a complex PDF which is having all the different elements, images, tables, and text. Then there is something called as unstructured. Unstructured is a um, application or a company, unstructured.io, which gives its libraries. So we will use unstructured.io library, which will do what? It will extract the images, extract the tables, and extract the text as well. Okay. Out of my PDF, usne kya kya? It has created 3 different groups. Let's say this image was having 10 diagrams, 10 images. So it has collected all those 10 images. Let's say it has 5 tables. So it has created, or it has, made a bundle of those 5 tables, and whatever text was there, it has created one separate group of text as well. Okay. Now what I'm doing is I am passing it to my LLM. Images has to be sent to what? An large language model, which is a multimodal already. Okay, which should be able to accept your images. So इसने क्या किया? It has taken this image and it has created its summary. Let's say you have sent an image of banana. So it will say this image is it will create its summary in the form of text. It will create some text like banana. If the image is of a cycle, it will say this is a cycle. So what it has done, out of those 10 images, I have created 10 different summaries. Okay, so far so good. Now at this point, I have 10 images and 10 different summaries, one for each image. Second is, now I have to deal with my elements which are tables in it. What I will do with the tables, similarly, I will pass my tables through LLM, large language model. Let's say I use Grok models or OpenAI models. And then what it will do is it will create summary out of each table. Okay, earlier I had the full table. It will do what? It will create some summary in the form of HTML. The tags बना देगा. For example, one tag like heading. I will show you all these things. Okay, just try to understand as much as possible right now. So it will create some summary of all those tables. Now we have 5 tables and 5 summaries. Let's say we have some text which anyway has no issues. So I will create summaries of those texts. Okay, I have 1 page of text. I will just create two-line summary of that text. Simple. Images, tables, and text. Now what next? Now what I will do is I will associate the image with its corresponding summary with the help of some unique ID. Let's say that ID is document ID. So this document ID is basically a link between this summary and this particular image. Okay, so that I know, okay, the summary number 1 is for the image number 1. Summary number 2, which is in the form of text, is corresponding to my image 2. ना ऐसा एक linking बना लिया मैंने. So that I know for doc ID 123, this is the image. For doc ID 234, this is the image. Similarly for tables and for my text document as well. ठीक है? Now what I'm going to do, I will put all these elements into some other database which is called as the document store. This can be S3 from Amazon or any other file system or anything like that. So this document store will basically store all these multimedia elements, and I just need to use a simple text embedding models, which I just showed you, right? Text small, text medium from OpenAI. I need not to use any model, multimodal like clip model, because I just have the summaries in the form of text. ठीक है, तो इतना सब कुछ करके मुझे क्या मिल रहा है? What I am achieving is I'm not using that clip model, okay, clip embedding model. So out of these summaries, I have created my embeddings as usual. Okay, so they will be placed in some vector space in this vector database. Now what will happen if any user asks any question? Let's say his question is, who is Ram? So what will happen? My search will happen on these summaries, because my vector database is not having these images and all. It is just having summaries. So I had one image which was for the Lord Ram. So it has created one summary that Lord Ram is, is going towards Sri Lanka or something like that. Lanka की तरफ जा रहा है वो. Okay. So now that summary is stored here. When I ask where is Sri Ram is going, then it will be able to find those relevant summaries. ये बिल्कुल same है, right? What we discussed earlier. Text embeddings, question, and the top 3 matching summaries have come out. Now these summaries are basically associated with doc IDs. So when we created embeddings, we also associated doc IDs with these summaries in the vector database as a metadata. Okay, so from that metadata, these are my 3 top matching summaries. I will also find what is my doc ID by looking into those embeddings metadata. Okay, this doc ID for the first summary is 123. Then I will make a search in my document store to pull the corresponding image. So it will pull that image. If there is a table, it will pull that table. If there is some text, it will pull that particular text. So now I have retrieved all these documents, and whatever question I will ask, that question will have all these information. Now it's up to me. I have all these elements. If I want to show the image of the RAM to the user, I have to deal with this image. I can convert it into base 64, and I can pop it up on the user's interface. Okay. So this is the whole purpose. What we are doing, we are using 2 different databases, one to store our text summaries, other to store the actual elements, and they are related with the help of document IDs. And once a user fires a question, search will happen on this summary. Okay. For all the images, I have summaries. If the summary, whatever summary which matches, the top 3 matches, I will pull the corresponding doc ID. With the help of that doc ID, I will make a search in document store. I will pull the original elements. and then it's up to us how we want to show the information to the user. Is it clear? So this is our overall approach. So this information again I can pass to the LLM along with my question, and then I will get my answer. Okay, so we are using LLM twice, at the time of creating the summaries and at the time of final. When the user asks any question, I will get the relevant context. This context can be sent to multimodal LLM, and then I will get my answer. Is it clear or any question?
Uh, Surinder, actually, this vector database, I know about how embedding and these things, but what
Mhm.
does work for this document store in our case, in our user case? Why we are using this document store?
Document store is kept because when a user will ask any question,
Mm-hmm.
okay, for
Mm-hmm.
example, my document was having, let's say, let me give you an example. Okay, let's say my PDF. I hope you can see my screen.
Yes, I understand.
Just a second. See, my main purpose is how to store the information which is there in my PDF, in my vector database. Okay, so what I have done is for all these images, okay, I
Mm-hmm.
have created some summaries with the help of LLM.
Okay.
For image, for example, this is scaled dot product attention. Okay,
Mm-hmm.
I have passed it across my LLM that created some summary. That summary is now stored in my vector database. Now, if a
Okay.
user asks any question about scale dot product, and if I want to show him, some textual answer along with the image, what I can do is I can again pull the original image from my document store, okay, along with some textual response, because this image cannot be as such saved in my
Vector database, you are
vector
saying like,
database, right? I can
okay,
vectorize it, but then it may be costly, right?
okay.
So I don't want to store all this information, right? But
So,
what,
okay,
instead of
okay.
saving the image vector, I'm converting it into some summary. Okay, my summary will have something like that. Whatever which is happening in this picture on this image, a summary will be created. For example, this is uh, mat mul operation, this is scale, this is masking, softmax. So it will create some summary कि इस पिक्चर में बेसिकली हो क्या रहा है, उस that we will create embedding only of that summary.
Okay, got it.
Okay,
Got it.
and once the if a user is asking any question on that summary, then that summary will come out, and from the summary we will get the original image as well from the document store, है ना?
Got it.
This is only to pull the relevant information out of my vector database.
Okay.
Where is my, okay.
So one thing, how it behave like in a backend. For example, we know about the concept now. In
Mm-hmm.
case of the large table image, we have
Mm-hmm.
only summary. A summary has a like a embedding and store in the vector store, and
Mm,
actual image, actual table is stored in the document store like S3 and all.
correct.
So in backend, if like for any query. Then against that summary, it will pick up that table or that image from the document store, like this one. Huh?
Correct. Exactly. So what happens is, if I have a table, that table will be converted into some HTML format. HTML format means it will say, okay, the header. Okay. So it will say this table is having these headers: name, employee email ID, employees date of birth, and things like that. Then it will create row 1, row 2, row 3. So what it will do is, the table which was very complex in my PDF, it has converted it into some textual format, some easy format like HTML or .md format. Now with that format, we can create some table. We can create some embeddings and we can store it in our vector database. Now the search on top of that will be very easy and very accurate. Okay. Anyway, let's do the exercise. Then it will be, we will run some code. So extract documents using overview of the flow, extract elements using unstructured. So we'll use unstructured.io. I will take you to the website as well. Extract elements, extract text, images, tables from the PDF documents, separate the documents into text, tables, and images, generate summaries using LLM, store the summaries in and the original chunk. The summaries can be stored and embedded for the later retrieval, forming the basis of the multimodal RAG. Query your vector store. Now you can use this vector store as a retriever and get the tables and images and tables, other things. Okay. So other than that, today I was trying, uh, some different things. Let me show you quickly. I hope you can you see VS Code?
Yes.
Okay, great. So let's say I have this invoice image. Okay. Okay. So this is an invoice image and it is having some tabular data. Okay. So what I can do is I created this IPYNB interactive Python notebook. I have imported base 64. I am using OpenAI library. I have set my key, created my client, and this I'm showing how you can pass your image to the multimodal LLM to read the image, to parse the image, to do the OCR on top of it. Okay. So this was my image, which is having a lot of details like invoice number, September, all these things. This is the amount and the payment information, email address, and other things. Okay. If my business is having such kind of data and they want to create some question answering on top of it, for example, in one of our account, the requirement was that they had millions of invoices, and what they wanted was to pull the information in the form of JSON and store it somewhere. So we did a project where these images were passed to the LLM. That LLM created some JSON structure, and that JSON structure was given to the client for their further processing. Once we get the extracted text, then we can do anything out of it. Okay, now because this table or this invoice has now been converted into some text format, some .html format or .md format, on top of which I can do searching and question answering. So for this image, let's say I want to read, this is an image, this is .jpg. If I want to read this image, what I can simply do is I can use these APIs. Okay, first what I need to do is I need to convert my image into some base 64 format. So this is that function which will help me. This is the image path. This is lying just in my same folder. This is base 64. I will give this path and I will convert my JPG image into some base 64. Now there is, I will use chat completion. Okay, so here I am not using LangChain. I am just using OpenAI APIs directly. So I will create the array of messages. Role is my user, content, type is text. Okay, type, and then type is image. If I want to send image in my request, then this is the syntax. This we have not seen in the past. Today I'm telling you, if you want to send image as an input to the LLM using OpenAI APIs, this is the syntax. Type is image URL. Image URL, you have to give URL and then the path and then your this image base 64 which we have created. Okay, so it is internally creating some URL. If you have any web URL, that will also work. Right now, we converted our image into base 64 and then we have created some fictitious path. Okay. In the user text, type is text. Here I'm giving my some text instructions like extract the text out of this image and tell me the number of guests who consumed beverages and amount for the same. if you see my image, there is food and beverage 300 guests, and the total amount is 2460. Unit price is 1230. If I need to do question answering on top of this image, I am sending my image in the input and also asking some question. Or let's say I ask it like, okay, extract the text out of this image. So this is the simplest way. Okay. So I have run this code. Client base 64 conversion, base 64 request, client.chat.completion.create. Done. Now if my response is in the completion. So if I see completion.choice is 0, if I run this one, so it has extracted the text. Now you can see how beautifully it has converted the image into this text. It also has retained the format, layout, whatever table which was there, it is able to retain that information along with the layout, subtotal and things like that. So now I am able to drill down into the textual details. Now, if I have any questions, okay, for example, I will comment this one now. If I have a question, I can directly ask to my LLM. After extracting the text out of image, tell me the number of guests who consumed beverages. So it will give me the text related to the number of guests and the food and 300 guests. This is the amount. Okay, this indicates that 300 guests consumed beverages and the total amount of this was 2460. Okay, so this is one of the most simplest way. Right now also in one of the project, I need to pull some information out of doctor's slip, right? Whatever doctor, uh, I'm right for the patient, the information and the invoices which are there. From the invoice, I can pull the relevant information. Okay, what was the disease? What is there is something
So,
called
Surendra, I think
ICD-9 code. Yeah.
I think previous OCR, what I remember, we have to,
Hmm.
we have to define like some specific text, a some specific column as a recognition. But with
Correct.
this model, I think it is very good. We can, convert the whole document in a text, and then we can search out only the text, and we can get
Exactly.
it like this one. Huh?
Exactly. This is very, very
And
efficient. OCR was
yes,
doing what? It was able to detect the text out of your given input document, but it is not able to retain the layout. Plus,
mm,
it does not have context. Since this is a large language model, it is also using OCR, at backend, maybe, there are a lot of things which goes, or some CNN algorithms are there, convolutional neural networks, which are very good at analyzing images. The beauty is it is also able to retain the layout also, what information is
yes.
lying there, and it also has the information of context, what you're talking about. If you ask question on top of it, it will be able to give you the exact answer.
Great. Because previously when the form was changed, then it was not
Yes.
working. Now I think it will match look 99% accuracy.
Yeah, yeah, yeah.
Because with previous product, what I remember for Captiva and capturing tool, they were
Hmm.
like 79 or 80% accuracy.
Correct. So you can also try this one. You can also try some handwritten documents as well and just see. So that
Great.
was one. So if you want to see the details, you can go to OpenAI, and then if you go to images and vision, I have taken this code right from here. Okay. If you have images and if you want the vision capability, this one, this is the exact code which I have taken. Okay, what is in this image and things like that. So there are some input requirements. What should be the size limits and all those things, their costing, their detail level. They also have something called low, high, and auto. Right, so that will also decide the accuracy as well as the cost as well. Provide multiple input files. Okay, all these things, how to calculate the cost. So these vision models are usually costlier. They are 8 times costly than our text models because they are basically scanning your image and uh, finding out the details. Okay.
So these are the multimodal or a specific vision model?
Yeah. They are multimodal. Multimodal and
Yeah.
visions are same, right?
Okay.
Audio and speech. Okay. So all these are multimodal. Audio and speech, that means they are multimodal. Images and vision, but they are specialized. Some are specialized for images, some are specialized for audio and speech. Okay, all those things. Now there are web search. All those things are also coming up. I will try to create some videos on this. Okay, chalo. So this was one aspect that we can use now directly these models. There is one model which was launched recently, that was Mistral 7B, I think. 7B model, generative text model, Mistral AI. No, this is not latest. Mistral. In 2025 only there was one model which was released. Models with vision capabilities, Pixel large, latest. Okay, so there are a lot of models. So this is also using almost, the syntax is same. Mistral AI, import Mistral, your key, your model name. This is just 12 billion. And then you can ask a question, your image in the form of, either in the form of URL or maybe in the base 64. This is the base 64. Okay, so you can try out these. They also must have given some use cases or some cookbooks which you can use. Okay, I read about one model which was in talk actually. Okay, some Mistral model. I don't know if these are those. Okay. And other than that, there is something called as Llama. There is called Llama Parse API. So just like LangChain, there is another company which is called Llama Index. So that Llama Index company is also having one this offering which is called Llama Parts. So what you need to do is, in the Llama Parts, you just give it a. So they have hosted this service at their end. All you need to do is and they have exposed their API. So you need to invoke that API and you have to give your input PDF file. And in return, they will give you .md format. They will convert that image into .md format and they will pass it to you. And then you can use that to insert in your vector database, basically. Okay, so this also you can try. Llama parts, this is also one of the famous. If you go, so they have UI also. If you want to test it, you can just go there and you can try. You can browse your PDF file or any image file and you can test it out. Okay, so I was trying this morning to get started. Let's say, so they have parse, extraction, and index. Let's say I want to use, so there are 10,000 credits which are available, okay, per month. These are free credits which are available every month. If you want to test it, you can just upload your file. For example, I upload the same invoice and I click on parse what it has done is it has also passed the information Sterling, Hotel, David, Thompson. So this is the text out of our, if you want to see in the form of text, this is markdown format, .md, this is in the form of text. So you can see this one also is able to maintain the tabular format. Okay, if you go to JSON, this is the JSON output, images. If you have any image in that particular invoice, then also it can show you it. Okay, so this is the image format. Layout, PDF, you can download the images. Okay, so they have given you option the different output formats which it supports. So you can try it out in the playground, and if you like it, what you can do is you can use its API as well to build your own application. Okay, so this was, if you go to the API, what you need to do is you need to create your API keys on the Llama index, and then generate your keys like that using in Python. Set your key, install all these things. This is the sample code. Okay, I also tried it. If you go to this one, okay, I created my key, passed the key, and then I just ran it. Okay, so this is the output. So it was some other input document actually. Okay, they have also given some cookbooks. So if you follow them, you can go to the GitHub. Okay, and there are some codes available in the GitHubs. You can go and try that multimodal. If you go into the multimodal GPT-4o, if you want to try it along with GPT-4o, they have already given a file. Okay. So for example, they have shown you how you can extract the text out of this complex table. Okay, this is the header and all. Okay. The code is also being given. This is how it is able to extract the text and retain the format. The tables, the biggest problem is if you simply create the chunk, what will happen? This chunk will go into this piece of text will go into one chunk. The next chunk will be like this one. Okay, if you define that my uh, chunk should be of size 1000 characters. So how it will break my table? It will break my table in the way that first 500 characters or 1000 characters will go into one context or one embedding. Second embedding will be of the next 1000 characters. But in the second embedding, you will see there is no header information. So if you do semantic search, it actually does not know what is this 72.6, because the header information is now lost. That was only in the first chunk. So that's why what happens, you have to store it into some .md format or .html format, which can retain the entire text into one chunk, and the header information is also preserved. So that's why their layouts are very important, or knowing the layout of your tables is very important. Okay, so you can try out all these different things. Llama index, and then I also showed you how you can directly use GPT-4o. You can also use GPT-4o mini, but that sometimes gives you limit exceeded error. So try GPT-4o only. And the third, which we will see today, is our unstructured.api. Let me take you to API of unstructured.io. Okay, ETL plus for GenAI data. Get started. So they also have different offerings. Okay, so they not only give you parsing capability, there are various other things which they offer. They can also help you to clean the data and a lot other things. Let me go to docs. This is unstructured.io. Okay, so if I go to API, so they also give the same API capability. You take your PDF and you just pass it. Okay, it will give you the output in .md format. Okay, second is there is one way where you can use it on your local itself, that is called unstructured open source. Okay, so this we will try today. We will install the freely available libraries on our desktop, and then we will use it to parse our documents. Okay, so this open source is definitely not that much efficient than the paid ones, these APIs and others ways, right? Because it's free of cost. Okay, and if you're using its APIs just like we did for the Llama parts, then it will give you more accurate results. But we will go through this open source one. Okay, so you can go through the documentation. There are a lot of information. What are the different methods are available? Uh, Partitioning, how to do partitioning. Okay, so these are the different files which are being supported. Email.csv, .eml, .message. All these files are supported by unstructured.api. You just pass these documents and it will be able to parse it. Okay, so let's directly go to our code now. समझ में आ रहा है everyone? या थोड़ा ऊपर से जा रहा है? Is it making sense?
Yeah.
कोई है
Yeah.
भी कोई कॉल में
Yeah.
है भी पता
Yeah.
लगा.
Yeah.
I'm
Okay,
just
no.
नहीं, यही है.
okay. This code is a bit complex. Okay, so Tesseract is another some Python API which you can use for OCR purpose. I think in the last slide I tried to cover that. Okay, so this one. So what are the limitations of this Tesseract? Okay, first of all, what is the difference between OCR and the LLM? If you want to do OCR of any image, how the OCR being done with the help of any API like Tesseract or Google Cloud Vision APIs or Azure's API, how it is different from using any multimodal LLM. Okay, so that I tried to capture. Okay, so if you don't want to use LLM, then you can just use this Tesseract Python API. It will also extract your text, but the major difference is when this is being done by your large language model, extract text plus understand the context, performs reasoning and generate insights. Okay, so this is the biggest advantage. It can retain the layout and it can understand the context and things like that. So it is one step ahead of normal OCR applications or libraries like Tesseract or any other. Okay, so this is, I mean, I just pulled this information from ChatGPT, so you can go through. Okay.
So, Surinder, nowadays people are just creating the application and trade it with the share market. So, I think they are using like that type of OCR technique with drops and alls and
Come again,
do the
come again.
transaction.
What they're doing?
People are making some like application,
Mm-hmm.
agentic application for
Mm-hmm.
the trading with share market.
Okay.
So they are using like that OCR techniques and to fetch out the graphs and things and data accordingly. They are, yeah, you can
No,
say
no,
like.
I mean, not like that. So
Mhm.
if you want to build any that kind of application, what you need to do is you need to use some BSC or NSE API. So there are APIs, I think money control or,
Yeah, definitely.
uh,
One
uh,
person, actually, one of my friend is using the Grow API
हाँ
from the Grow.
हाँ grow application.
But how they will identify like things with the specific charts and
No,
specific
see,
graphs?
you will create those charts, right? If you are
Mhm.
building an application which can create insights for the user, then you have to consume the data from these APIs and you have to create your own charts. You are not basically, see, you are not analyzing a given piece of image or a given piece of chart,
Okay.
right? You are creating your own graphs with the help of data. So that, I mean, that is a complete reverse of what we are doing. We are trying to analyze the images which
Mhm.
are already there. In case
Okay.
of a stock market, I mean, we can do some kind of uh, real time, at the real time we can pull. I mean, see, again, stock market applications are also of different type. If you want to do something on the real time, like what you call this trading, basically, right?
Correct.
Live trading, if you are doing your buying, doing FNO kind of things also, then you need the live data, which can, which is generated as soon as possible. वो फटाफट आपको consume करके you have to. Second is, if you are doing some analysis, like for example, how much returns Reliance has given in the past 15 days, for past 15 years, whether is it a good time to buy Reliance as per the previous trend? Is it going to give me 10-20% in the next coming 1 year? वो एक long term perspective हो जाता है, right? Usually, whatever data which is being shown by Zerodha and all, they are pulling the data and they are creating those graphs dynamically.
Okay.
ठीक है? If you talk about the stock markets, what you can do is you can I have some recommendations for you guys. You can buy Trent. You can also buy Reliance right now. Okay. I mean, these are the hot stocks as per me. And what else? Let me open my wish list. Sorry, I'm just deviating from our topic. This is also one of my favorite topics.
Is it Reliance Industries?
Yeah, Reliance Industries. It is trading at a good price. And you can also buy CAMS. CAMS is a company.
Like CDSL one type?
Exactly. CDSL one types, not CDSL. Matlab, the business is of this, the stock market, like CDSL, and what is the other one? NSDL, CDSL, NSC, right? Indian Hotel is also one good stock. Okay, so this trend, and they don't give actually chance to buy. They rarely give it. Right now, it is trading at a very good levels. Other than on mid cap IT, you can focus on Coforge and Persistent. ठीक है, so these are Polycab. थोड़ा सा competition आ गया. Okay, otherwise it's also trading at a good price, but they are facing. I think there is one player who is coming in the wire segment. I think it is Adani. Okay, so that's why. One is other is PBL, which is Varun Beverages. ठीक है, so these are a few my favorite stocks. चलो ठीक है, sorry. Titan and Pidilite, they are also at good price. ठीक है. Okay, so we are about to run our code. So let me run this one. So what we are doing, we are installing all those required libraries: Tesseract OCR, libmagic, Popular Utils. There are a couple of libraries which are useful. Its installation is usually very messy. Sometimes it works, sometimes it does not work. Okay, it's like that only. So this is only for the illustration purpose, that this is what is one of the approach. Again, what you should do in real time, it depends on your requirements and lot other things. So this is may not be the most ideal way to deal with the complex documents, but this is one of the ways which is helpful for understanding. Okay. So in unstructured, you have like all docs. That means the library which we are installing will support all type of documents. As I said, they basically support a lot of these many formats: partition CSV, partition docs, email. Okay, so for each they have created a different library. If you are sure that your application is going to get only doc, then you can just install .doc. If you are not sure, what you can do is you can simply install all docs. That will support all the formats. Okay, Chroma database, tick token, LangChain community, Python environment. python.env. So all these libraries are required. But so what we are going to do, we are going to use this attention PDF. Let me show you the PDF one more time. So attention is all you need. You can see, I mean, just see it from its layout perspective. So this is one of the headings. This text is vertically aligned. There are a couple of user names and their email IDs, then some text, then there is some footer. Okay. And then this is the first title. It has some text in the first title. This is the second title. And then you can see there is a diagram. Okay. Diagram has a caption. Then we have subheadings, which is explaining this diagram. We have encoder, decoder, stacks. Okay. Then again, I have some diagrams, images. I have some complex formulas. You can see. Okay. So if I have any question on top of this formula, just think how difficult it is to store such things in the vector database. Okay. You can see the symbols, different symbols being used, subheadings, and now I can see there is one table, positional encoding, some formulas, sine theta, cos theta. Okay, so this is pretty complex document, right? If let's say I am asking a question like, what is the value of MOE32? What is the blue score for the model MOE32? Okay, if the application which we are going to build is able to answer 26.03, then I think this is wow, right? The application which you built last in the last session, if you give this PDF and if you ask questions like all these things, what is the value of blue score for this model, that won't be able to tell anything about these tables or the contents. Today, it, it should be able to tell all these questions which are around this table. Okay, for example, if I have quarterly results of any company, and if I want to ask on top of it, what is the growth quarter on quarter or year on year, what is the mm, sequential growth or EBITDA and things like that, it will be able to tell you. Okay, so this is pretty complex PDF which we will be using today, and my libraries are installed. Let me enable them. Google. So our first aim is to extract the text, right? As we saw in the diagram, my first aim is to extract the text out of my complex documents. Okay, extract images, text, and tables, things like that. So this is NLTK. So I was getting a lot of exceptions, so I kept on resolving those. So that's why you will see some imports here and there. So now I'm on the unstructured API. Okay. So what I have to do, unstructured.partition.pdf.partition PDF. So there is a function called partition PDF, which will help me to parse my PDF. This is the output path. This is my file path attention.pdf, which is placed right here. Okay. And then chunks. So this method I will use partition PDF. What are its parameters? These are very important. First parameter is file path. Okay. Chunks, this partition PDF is coming from here, right? Partition PDF, this import. The first parameter is file path. Okay. Definitely my function will need from where to pick or take the file. Second is infer table structure. If you want to extract the tables, okay, you need to make it true. Okay, infer table structure. At the same time, I have to define my strategy there are different values for this strategy. Okay, right now I am using high underscore res, which is mandatory for tables. If I want to pass tables and pull the information out of tables, I need to use strategy as high res. If you can see, all these details are given in the reference as well. Okay. Partitioning, unstructured. These functions break the document into elements such as title, narrative text, list items. Okay. You can explore this. You will get partition. Partition CSA. So this is for different. Okay. So this is strategy is high resolution, high res. Okay, so these are the two settings to get my information out of the tables. Extract image blocks, image. Okay, so I can also give the table. In that case, table will also be extracted as an image, but I don't want that. Okay, I just want the textual details of my table. So I have made this setting as true. And here I am just putting image, add table to list the extract image of the table. If I want to also pull the table as an images, then I need to put comma and then give the table. Right now I don't. Image output directory, or if I want to pull the images and store it into some output directory, I can do that by giving some value to this parameter. Extract image block to payload true. That means what will happen, it will give me the images in the form of base 64 as well. Base 64 format. We have seen, right? We did a couple of examples. What do we mean by base 64? If I need to pass my image to my APIs, I need to convert my .jpeg or any input document into base 64. Okay, so that I need that because I want to use base 64 format to display on the UI. So I have made it true. Second is chunking. Okay, let me comment this one. Okay, so this is actually deprecated. Okay, just wanted to show you that this setting has been deprecated. Okay, so be careful if you see this setting in some cookbook here and there. So if I, let's say, if I run this one by commenting out this particular thing, what is happening right now? We are using unstructured library to parse my attention PDF, which was, 13, 14 page PDF, and it will extract all these things. Okay, it does take some time. Okay, so it is using YOLO-X. If you go on internet and you see what is YOLO-X, YOLO-X is an advanced object detection model developed by McGill Research building upon the YOLO. Okay, so these are basically some machine learning models which help to analyze the images. Okay, so these unstructured API also uses couple of models in the backend. Okay, so everything is being, this is 217, so it downloaded that model into the local machine and it's trying to parse my entire PDF into. So what is the strategy? How the unstructured API works? It works in the way that whatever input document which we give to unstructured API, it will create different elements out of it. Different elements in the sense, it will say, okay, this is heading, and this is text. So it will say, it will create one text element and it will put this text into that text element. If it finds a footer, it will say there was a footer element and it will be placing this text in the footer. Like that, it tries to pull each and everything in terms of elements. This is heading. It will say heading 1 is introduction. Text 1 is this text. Heading 2 is background. Okay. And then it will say diagram 1 is this image, or image 1 is this image, image 2, image 3. So it create different type of elements and it store the different elements into uh, s- uh, different artifacts into those elements. It is taking a lot of time.
So, Surendra, if PDF is having different language, like if let's suppose it is having in Marathi or something else, Indian language, so
Mhm.
that also we can work with that, or
Yeah, I
only
mean,
English?
these multimodal models are
Mhm.
capable. Whether unstructured is not, I think need to look into the documentation, whether it is able to support the different languages or not. If you're using OpenAI models, I think it should be able to understand that. Can we have session tomorrow as well, guys? I want to cover one session on agents as well, since in the last week we were not able to do it. Will that be fine?
Yeah, I'm
Yeah,
okay.
yes, I'm okay.
What time?
Same time,
Sir?
same 6 to 8. Will it work?
Yeah, this time works for me. Yeah.
All right.
Yeah.
So what I have done is this method basically creates some chunks. Okay. And in this loop, what I'm trying to see is what are the different type of chunks which it has created. Okay. String, type, EL. Okay. Whatever chunks I had, I have created one for loop. Each chunk is in the EL and I'm finding what is the type of EL. So it can say, you can see that the different elements which it has created are of different types. It has created one email address. Okay, so this is one of the elements dot email address. It was able to find emails, figure caption, footer, formula, header, image, list item, tables, text, and title. Are you getting? So this API does what? It pulls the different type of elements from my input document. Okay. And if I go and check how many such chunks are created, so it says there are 220 different chunks which are available. Maybe 10 footers are there, maybe 20 formulas, some headers. But in total, how many elements were fetched? There were 220 elements in my entire PDF. Okay, if I want to see what is there in my 10th chunk, because this chunk is what? This chunk is a list of different elements. Okay.
But we can also define the number of chunks as well as overlap parts and all what we did
No, no,
previously.
no,
No?
no, no.
Okay.
Type is a list. Okay. So there is a list of chunks of these elements. Okay. So there were 220 chunks which got created. If I look into the 10th or the 11th chunk, it is of type title. ठीक है ऐसे 220 चंक इसने बना दिए ठीक है बट व्हाट आई वांट इज आई वांट टू डू some grouping, right? Right now, it has created maybe 10 different email address, 20 headers. So the information of my PDF has got into different elements, but they are not structured together. Structured in the sense the context is not grouped together. Getting? So what I can do is I can define one strategy. Okay. I will say what you do instead of creating 220 chunks, you group my chunks by some strategy. Okay. What in that case, what it will do is if my image one and if my email address two and formula they are lying in on a similar page, it will group them together so that the context is retained. Are you getting? What it will do is it will see, okay, this is image two, image three, there is one caption, there is one heading, and they all are talking about the same thing. So what it will do is it will group these many chunks into one group or into one composite element. Getting? And it will store all the relevant chunks together. Getting, guys? So what it will do, it will see
Mhm.
there are images. For example, when it is parsing page number 4, it will see there are two diagrams and these diagrams are very near to this one. And in the next header, we are talking about the scale dot product. So it will create one parent chunk which will have all these sub chunks, two image chunks, one title chunk, one maybe formula chunk, so that my information is grouped together. Similar information is grouped together. है ना? So now what will happen once I group my semantically similar things together, my number of groups will go up or number of chunks will go up or down?
Down.
Down, right?
But it
So,
was very, very easy with table, group by. But with text and these kind of things,
exactly. So this
it's
has
very
become,
difficult, huh?
and our approach is also very difficult, right? I mean, I could have just shown you the first approach, which is very much simple, right? Just pass the image and you will get everything from the LLM. But I just want to show you the minute details, how difficult it is. Today, if you are using LLM, it may not be, uh, evident to you how difficult it was some time back, right? So this is just to explain you the intricacies, or how these products are made and what is the complexity running behind them. So that's why I always choose to go through the toughest path, so that you learn as much as possible. If you talk about all these things in any interview, that will definitely help you to crack the interview, because they will come to know, okay, he knows all those things, that even YOLOX is running behind the unstructured APIs. They are also using some ML things. And what are the different options? As I told you, if you say in an interview, okay, I dealt with these complex documents, he will ask you what was your approach. So you can say, okay, I tried this approach. First I tried using llama parts, but then it was taking a lot of time. I was not getting the desired output. Then I switched to the LLM, but it was costly, and my company wanted to have some solution which is of open source. So I ended up using unstructured API, which is free of cost. Again, unstructured also gives you the solution in 3 or 4 ways. You can also use their APIs, okay, which is again costly. So I used finally unstructured.api. I installed the libraries on my system. It has this partition PDF. You have option whether you want to. अगर ये पूरी कहानी सुनाओगे ना, I mean, you will be able to crack those interviews. And anyway, you are having these details, right? This is not a shortcut. You know, you are learning all these things. Okay, so it will
Right.
taking some time. Agent also we will learn in the very, toughest way. Why do we need agents? We will try some simple things in the Python, but then we will realize, oh, this is missing, that is missing. No, I will not directly jump to any framework and will explain you. Those frameworks make things very easy, but this is not how the things are once we, do some real life projects.
So for that thing, Surinder,
Hmm.
you are saying a very good point here.
Hmm.
So what about this LangChain and Llama Index? Because these are the framework.
Hmm.
So is it okay we are using direct this framework, or we can go just like a vanilla one?
No,
Do-
frameworks are actually very important actually. So if you are
Mhm.
using, this is a, I mean, good point. Okay, it's a plus basically. Learning LangChain is also very complex, so that's why we have learned all those difficult concepts. It makes the things easy, right? And I explained you why do we need such frameworks at the first place. If you are only doing very simple thing, for example, what we did today, we just sent one request to my LLM and I got my invoice passed. If I'm doing only such thing, then why I will use LangChain, right? If my application is simply my user is giving some content and I am just summarizing it and giving it back to the user, then I will use OpenAI API. Why I should need LangChain or Llama Index? I need those frameworks because I am developing some complex applications. I'm creating long chains. I'm creating agentic applications also. Okay, where I need to do a lot of processing of the output also. I need to give output of one component into as an input to the other component. In between, I'm calling my custom function. So I need to stitch all those components. वो पूरी story है ना, आपको बतानी होगी. ठीक है? So now How many chunks are there? They have just 12 chunks because it has grouped the chunks into different composite elements. Okay. So this is what composite element. All these chunks are basically composite elements now. Composite elements in the sense they are having other elements inside them. Okay. Type chunk, this is unstructured or composite element. Okay. If I convert it into dictionary, I can see type is application, last modified, page number is 10. This was the original element. Okay. File name is attention.pdf. So all these details are there. What I did, I just took one chunk, the 11th chunk, and its metadata I stored in this element, and then I converted into dictionary to dict. So this is the metadata of my 11th chunk. Okay. It can, so these are the different metadata, like what is the PDF type, last modified, where this chunk is coming from. It's coming from page 10. And this is the original. I think this is an image. Maybe this is base 64 format of that image, maybe. Okay. So what next? Fourth chunk, it's metadata. I have, what I'm doing is from the fourth chunk, I am taking out its base elements, right? Because I'm going into metadata, going to original elements. So this will give me the different elements my composite element is having. So if I iterate it through and I am checking if it is an image, then I'm creating one list or the bundle of those images. Okay. Are you getting? मेरा aim क्या था? My aim was to create the group of images, isn't it? So I am gathering all my images. I am checking that if there is any element in my composite element which is having image, so I will store that in my this object. If I see, if I take the first element, if I convert it into two dictionary, I can see the type is image. Why it is storing only images? Because I have put the condition, right? I am iterating through all the elements and I'm saying elements, if it is of image type, then you store it into this
And
object.
right now, where we are storing these images?
They are just in this object, chunk images.
Okay, in memory, correct?
In memory.
And we can save that images also in S3 and like document store.
Sorry.
We can save also that images in document store.
हाँ वो
What we
करेंगे
have
अभी
put.
करेंगे. I mean we will do it. Right now we are
Okay,
just processing.
okay,
ठीक है?
okay.
We are just gathering all those things. सारी
Hmm.
images को in one object, tables को one object, text को one object. We will create summaries. उसके बाद last में जाके we will save all these things.
Okay,
Okay.
got it.
And before that we also need to create this document IDs. Okay. So all that stuff. So this is, I'm just showing you the different details, minute details in this chunk list. My first element, if I see and convert it into dictionary, it's definitely of image type. This is ID. These are the coordinates. Coordinates in the sense, this is also having the information where exactly my image is this. For example, if I talk about this image, this is having some coordinates in my PDF document, right? From top, it may be, some 20 inches from right side, all those things. So all those details are also saved. From where exactly, what are the coordinates of my this particular image in my PDF. All those details are there: pixel space, width, height, modified, page number, fourth. That means this must be, this is which page number? Third page number. Okay, sorry. This is page number 4. So I think this is one of these images. Okay. Okay. And this is image base 64. Why I am getting base 64 value also? Because in my input parameters, I explicitly said I need my base 64 also. If you remember. ठीक है. Base 64 कहाँ गया? This one. Extract image block types image, this one. Okay. If true, we will extract the base 64 of the API. If I make it false, this tag will be empty basically. ठीक है? ठीक है, अब मैं क्या कर रहा हूँ, सेपरेट एक्सट्रैक्टेड एलिमेंट्स इनटू टेबल टेक्स्ट एंड इमेजेस। ठीक है, इमेज तो मैंने कर ही लिया है। राइट नाउ कंपोजिट एलिमेंट स्ट्रिंग टाइप, ये मैंने टेक्स्ट को इकट्ठा कर लिया। दीज आर माई टेक्स्ट एलिमेंट्स। Similarly, what I will do, I will collect all the tables. So this table will have all my tables, and you can see, I said right, the table information will be stored in the form of HTML, layer type, complexity per layer, okay, maximum path length, all these things. So how many tables I have? One, two, three, four tables. Okay, length of tables is 4. There were 4 tables, and all of them have been converted into HTML format. Now this text can be saved in my vector database, right? It has all the details. What is the row 1, row 2, row 3, things like that. If I see length of, I have 7 images. Okay. Check what the image looks like. Again, I have written this method which can display any image if the input parameter is base 64. I already have the base 64 format, right? So if I pass that, I can see this image. The second image is this one. If I do it like second image, third image, then this is the image. So now you can see our API is able to pull or extract all these images out of my PDF document. ठीक है? तीनों का bundle बन गया है, right? Now I have all these groups. My next thing is to create summary out of all these things. Summarize the data. Text and tables. इसको जल्दी निपटाते हैं. So what I'm going to use? I'm going to use, I think Grok, I was facing some issues, so I will use OpenAI only. Okay, so I'm creating summaries and I'm making use of my large language model. So I have my prompt like that. You are an assistant tasked with summarizing tables and text. Give a concise summary of tables or text. Respond only with a summary, no additional comment, and I will embed my element. Element is my variable. So this is my prompt, chat prompt template, dot prompt template, prompt text, which is this one. And then this is my model, which is 4O mini. And this is my chain. This is my lambda function. This is my prompt model. ये सब आपको पता है, right? तो ये क्या करेगा? We have given it the different text elements. Summaries को अगर देखें, the encoder has 6, sorry. ठीक है? So it has created all those summaries, multi-head attention. Okay, and we are this time for the very first time we are using the batch operation. Okay, so batch operations are cost effective also. If you go to OpenAI website, there you can see the costing for batch operations are usually less, because what we are doing is we are passing three requests in one go in a single batch. Maximum concurrency is 3. So what it will do is it will take 3 elements and it will send to my chain and it will revert with the summaries. So ये सारी summaries बन गई उसकी. Okay, makes sense? Now I have started creating summaries with the help of LLM. Summarize tables. Now I want to summarize the tables also. I created this table HTML, table summaries, summarize.chain batch. This time I am sending tables underscore HTML. Again, batch operation. These are my table summaries. So you can see the table compares to different layers on complexity, sequential operations, the maximum. Okay. From the HTML format of my table, which was extracted by unstructured.api, I'm now able to create these summaries and large language model is helping me out. तो जो भी टेबल के अंदर था, it is now able to create summary out of it. ठीक है. Similarly, we will create image summaries as well. And what is the format? We have already seen the format in our previous example. I'm not using, am I using LangChain? No, I'm not using LangChain. Using LangChain. Okay. Okay. Prompt template. This also has a similar, uh, uh, what do you say, syntax. Type is text. Text is prompt template. Type is image URL. Image URL is this one. Okay. If I see the image summaries, what it is saying, provides a clear path to follow the process, make it easy to understand. Okay. The image illustrates the architecture of a transformer model. I think this is talking about our first image. Okay. इस image को हमने first we extracted and now we have passed it to my LLM. Now it is able to describe the entire process, because now you can see the beauty. With the help of LLM, I have created the details of this image. Okay. Multi-head attention. Now I can also ask questions on top of these headings also. What is feed forward? What is multi-head attention? And things like that.
Correct.
This illustrates the architecture of transfer model featuring several key arrangements in a structured flow chart. Overall structure diagram is divided into two main sections representing the encoder in the left side and the decoder in the right side. See, that much of details it has captured. Now, if I ask any question, once I embed this thing in my vector database, and if I ask any question on, explain me the left side of the transformer. So what it can do, it can definitely explain you because it has now captured that level of details. है कि नहीं? So this is the beauty. ठीक है, अब now we have created summaries of all those things. Next step is, this is just to display the first diagram, okay, for which we created the summary. Okay, print summaries, for example, ये first image की summary है. This is the diagram. If you do it print, it will restructure the information, ना formatting हो जाता है, थोड़ा सा अच्छे से दिखता है. Now you can see overall structure. The diagram is divided into two main parts: encoder side, input layer. Encoder side के अंदर भी it is able to say input layer क्या है, what is position encoding, and layer, all these things, input embedding, positional encoding, multi-head, all the details. It has created such a fantastic summary that even if you ask any question on this one, then it will be able to answer and it will be able to pull this image in your application also. Okay, so ये सब हो गया. Now the next step is to load these data, create the vector store. What we are doing, we will be using Chroma database, and there is, from the LangChain, there is something called the multi-vector retriever. Okay, that we will use, which will run on top of Chroma database. Okay, so these are the different imports. Chroma in memory store. This is for storing our documents, the actual content, images and tables and things like that. Okay, this is the document object. This is OpenAI embeddings. This is multi-vector retriever, which will help me to retrieve documents from my vector database. Okay, this is my vector store, Chroma. Yeah.
Surendra, what would be the
Hmm.
best way to store the in memory or store to some document store?
I mean, since this is just a simple code, I am using in memory. But if you are actually doing it at a large scale, then definitely you need to use something which is persistent and bigger, and which can store a lot of data.
And performance wise, what would be the better? In memory or document store?
No, in memory means it will be there in the memory the time we are running this code. Once I exit from my Chroma,
Yeah,
from
so it's
this
not
one,
persistent. Yeah, it is
it's
not
not
persistent.
persistent. Correct.
Yeah.
So you have, for real life examples, you have to use some any other.
Document store. Okay.
Okay. And then, so this is my Chroma, collection name is this one, embedding function, I am using OpenAI embedding. So whatever embeddings which will be created with that will use OpenAI embedding model. I think by default it will take, है ना, जहाँ यहाँ मैंने आपको दिखाया था, right? There are text small, text large. So I think when I say open embedding, it by default uses one of those. ठीक है? I can specify name also. अरे क्या हो गया इसको? पता नहीं. ठीक है, इसको you can see what is the default method. I think it uses small one. ठीक है? It has used that embedding model to create my vector store. This store is in memory store. This is also coming from my lang chain. Okay, and then this is my retriever, and this is also important ID, the document ID, which will create the link between my image and summary. So now while creating this multi-vector retriever, which is also from my lang chain, what I'm saying is I'm saying this is my vector store. This is my store for saving the original elements, and this is the key which you should use to link them. ठीक है? Everything has been done in the single statement. I have used it for simplicity. ठीक है? I have created such a retriever who has information of the vector database, our document storage, and the linkage between these two, which is ID. Okay, so these things are ready. Now I am all good to store. While storing in the vector database, as I said, whenever I am saving or creating embeddings of my summaries, in the metadata of that summary page content, I am creating here this LangChain document. Okay, this is my LangChain document. While creating the document, I'm saying my page content should be the summary which I have created, and the metadata should be having a key called ID underscore key, and the value should be doc ID. ठीक है, इसको मैं iterate कर रहा हूँ. This I value will keep on changing for different elements. First element will get document ID 1, the second 2, 3, 4, like that. Okay, automatically it will generate, and automatically it will associate each unique ID with the each summary in the metadata. ठीक है, this is done, and then I will, whatever it will create, I will add it into my vector store and also in the document store. ठीक है, document IDs and text, everything. ठीक है, and then tables, for tables also I have done the same thing. I'm whatever table list I have created, I am just iterating through, and I'm associating one unique ID and storing it in the vector store and document store. ठीक है, images के लिए भी same thing. Clear? By this step, what I have done is I have stored my things into vector database and document store. ठीक है, अब आ गया रैक पाइपलाइन. अब ये काम तो हो गया. सॉरी, हो गया. This thing is done. Now I need to create some chain so that I can ask a question. It will go pull the summary. From the summary, it will pull the document and you will send it to the LLM. Okay. RAG pipeline. So build prompt. ये थोड़ा सा complex है. Okay. This is my chain. There are two different chains. One is the chain and other is the chain with sources. Okay. Let me first show you the output. My response is chain.invoke. Which chain I'm using? The first one. Chain.invoke. What is blue score for a model by net? Let me see if it's working. Okay. The blue score for ByteNet is 23.75. The blue score for ByteNet is 23.75. ठीक है, सही आ रहा है. Let's say what is the blue score for this model? Conv S2S. The blue score conversion is 25.16 for English to German and 40.46 for English to French. C. English to German, DE. अब देखो, I mean, how
Correct,
intelligent it
correct.
has
Yeah.
become. It can tell you this DE means German, FR means French, and it is giving both the scores. ठीक है? So this is the beauty of this thing. Now I am using chain with sources. Okay, so my response, what I am doing is with the response, let me see what is attention mechanism explained with image. So whatever response which I will get for text response, print text, page number, image in the image. So whatever image I got, I'm again using the same function to display, right? Because it's now up to me how I can display the image to the user. ठीक है, तो ये इसने, it was the question, attention mechanism. Okay, so it has shown this image. If I go to, this, you understand what is attention mechanism, by the way? I explained maybe in our session. Attention mechanism is basically why transformers became famous, because of the attention mechanism. Okay, attention means giving leverage or importance to the most important part of your sentence. Okay, giving more emphasis to the most important part of your sentence. For example, this is a sentence like it is in this split that majority of attention governance. So what it is doing is our this transformer model calculates the weights, or like it will take one word and it will see how important this word is with respect to it, is, in, this, and it will create some weights, and then it will find out which word is important. Okay, so that is called attention mechanism. ठीक है? For example, our sentence is Ram will go to Ayodhya in, Ram may go to Ayodhya in May. Okay, so it has different words, right? So the beauty of transformer is that it evaluates the attention or the importance of each word with respect to rest of the words in the sentence, and it assigns some weights. Now, in my sentence, Ram may go to Ayodhya in May, it has two May, right? One is the month May and other is the English MAY, May, right? So how it is able to differentiate? Both are having same spelling, right? How it is able to differentiate that the second May is, we are talking about the month. It is all because of the attention mechanism. Okay, which basically evaluates every word with respect to the other words. For example, it will ask any questions to itself like who is going, where he is going, when he is going. Okay, Ram is going, where he is going, Ayodhya, when he is going, May. है ना? So that is called attention mechanism. So my question was, what is attention mechanism? Show it with the help of the diagram. So from my doc store, it was able to pull this diagram also. ठीक है? Now you can build any application where your application will not only respond on the questions for which the details are inside your tables or images, also it will pull the relevant images along with your textual response. Getting? तो ये इसने आपकी इमेज भी ला करके दिखा दी. ठीक है? ठीक है, सो इट इज सेइंग ये सब अटेंशन मैकेनिज्म होता है. देयर इज समथिंग कॉल्ड KQV, कीज, क्वेरीज एंड वैल्यूज. वो कैसे काम करता है? इट हैज एक्सप्लेन्ड यू. स्केल डॉट प्रोडक्ट, मल्टी हेड अटेंशन, all those things, visual representation, first image, second image, third image. ठीक है? So this is how basically you can deal with these type of complex documents, and lot of code has been taken. For example, multi-vector storage, यहाँ पे मैंने link दिए हुए. You can just go through these links and you can, some code you can find there. Okay, they have their cookbooks. This is from LangChain itself. If you go, they also have similar thing, right? How to do multimodal RAG, semi-structured data. What is the option 1 using the clip models, option 2, option 3. ठीक है? ये मोनालिसा की फोटो है. these are the images. Multimodal, it will go into some multi-vector retriever answers. So you can go through this documentation. This is very useful. So this part of this collab file. Okay. This is a bit complex. Which one? Making this one. Okay. So you can try understanding yourself. If you're not able to understand, maybe we can discuss. Okay. Runnable lambda, runnable pass through, all the concepts we have already seen, right? Context. When you ask, when we say chain with sources dot question, that question will be passed to my retriever, who will pull what? Who will pull the documents from the vector store, and those documents will be given as an input to my runnable lambda, the pass document method, which is this custom method. Okay, the document will be passed, and then it will be set to my context and my question. These two things will then be again, I have something called runnable pass through dot assign. Then whatever question I have asked, that will also be runnable pass through dot assign. One more key will be created. मतलब थोड़ा सा complicated है, okay? You can Google it and try to understand. And then runnable lambda, this is my prompt. I have the context, my question, and then I will pass my prompt, my model will be used, and the final answer I will receive. ठीक है? Are you with me? All four participants are
Yes.
still with me.
Yeah.
I know.
Yes, yes. I'm
Yeah,
here.
I mean, I know this is the one of the most tedious or complicated lecture of the entire course. But yeah, I hope this has given some insights to you guys.
Yes.
Yeah.
So I will share this particular collab file, and lot of other resources are also shared. Okay, go through the llama parts, how it works, and then how we can directly use multimodal LLMs. This unstructured API, this is a free, right? You can build your application free of cost. This is running on your local machine. Okay, and any questions, guys, before we close for the day?
Miss Surendra, like for 2 year experience guy, how much they are expecting? Like we should know all the concept of like advanced rack, everything. Like what is the
No, no, no,
provision?
no. I mean, I don't think. I mean,
Uh-huh.
they ask just basic questions. You should be able to understand
Mm-hmm.
the,
Okay.
what is LangChain, how you can create
Sure.
simple I mean, very basic. For 2 years, it's like
Mm-hmm.
cakewalk, you know.
Okay. Okay. Mm-hmm.
Just tell them I know this runnable pass through and all those things. The interviewer might not be knowing all these things.
Mm-hmm.
Whatever we have learned in the last few all the lectures, just try to build some stories and pass them.
Mm-hmm. Okay.
Yeah,
So
Surendra, please share last session video
yeah,
also
let
when
me
you
check
upload.
here how it is possible. I uploaded something
Surendra,
else.
what session happened on last Sunday? I unable to join that.
Okay, so
Do
this
you have
is RAG,
recording?
na?
Last
This
Sunday,
is
nothing. I think nothing
huh,
much. Huh?
last Sunday was
We
nothing.
we
Last to
just
last week.
connect and then yeah.
Oh, okay.
Yeah, last to last week I'm talking, Surendra.
Ha ha.
When you have a
This
RAG
is the
one.
one, na?
Yeah.
RAG.
Okay. Can you just post this one on the
Yeah,
chat?
sure.
And Surinder, actually, we what we did on the Google Colab with the Renewable Pass-Through, I was able to use the Langsmith and logs
Mm-hmm.
were created there. But with
Mm-hmm.
this advanced LangChain and onboard assistant, I
Mm-hmm.
tried too many times, but it was getting issue, and
Mm-hmm.
this it is not generated the Langsmith there logs.
Okay, Langsmith logs.
Yeah, but everything is working fine. I'm getting over
Mm-hmm.
this stream date application and just do the test there. But this, Langsmith, it is not created there.
Okay, okay.
When I disabled it in the environment file, then application working fine. And with Langsmith, application was not working fine.
Oh, I think this is the Saran AI Live default one, right? We did it last week, correct?
Yeah, Runnable
I
one is okay. Runnable was okay, but
Mm.
with this one, this onboarding assistant app with
Mm-hmm.
Streamlit application, I was tried to do this Lagsmith integration with there, but it was not working.
So today also everything is being captured. I mean, did I enable it? I don't know. What is the attention mechanism? Everything is there in the Langsmith.
Yes, yes. I think in Google Colab code you have mentioned there is a V2, huh?
Okay, okay. So this is
Thank
all
you.
today's, all these
LangChain.
tables
So
and
you
all,
have enabled LangChain tracing V2 in
Uh,
today classes?
that's what I'm saying. I didn't.
Then why it
I
is
don't
creating
know.
today?
I think there are a couple of properties which are there in the secret manager, right? Maybe because of where is that? See, mines are getting created without configurations, and yours are not getting created.
With Google Colab it is created, no
Acha,
problem.
Google Colab.
But with this Visual Studio Code, I'm getting the
Mm-hmm.
issue. Okay,
Okay.
no problem. I'll try again. Then we'll let you
Mm.
know.
Fifth
So
four.
for designing, we are using Streamlit, Surendra. So like
Yeah, yeah.
apart from that, we have to maintain the CSS file for designing the pages.
Yeah, I mean, see, our job is
Hmm.
not to create UI also, right? So there are
Acha.
different roles in the project. We are mainly
Hmm.
dealing with the generative AI piece.
Hmm.
We
Hmm.
will deal with, how
Okay.
to uh, build application using Python and how to invoke LLM and how to, I mean, business logic, right? Front end,
Hmm.
there is an entirely different thing. Different
Hmm. Hmm.
team will be there. For cloud also, there is a different team, right?
Hmm. Hmm. Hmm.
Yeah.
Okay.
ठीक है. All right then.
So, Surendra, last question. Like,
Yeah, please.
if I talk about opportunity in market, so for the Gen AI, we are having like openings frequently, or should we have to wait for the opportunities?
No, I think there are
Uh,
ample amount of, I mean, opportunities these days.
okay.
This is the only area
Uh,
where
mm-hmm.
there is no recession or there will not be any, I mean, recession because recession is because of this only, right? AI and all.
Yes, yes.
Yes, you are right.
Surinder, I have one question.
Mm-hmm.
How it so far what we have seen what we have it, how we can basically simplify it and make more better uh, friendly user friendly kind of content. How we can really generate the new part of it. I give cat and bring out something as a different image,
Mm-hmm.
and those kind of things we haven't seen that.
So I mean, that is actually a part of diffusion models, diffusion. Generative models used to create new sample data, particular images. Okay, so whatever you see, like, for example, in the chat GPT, you have Sora, right? There is one more now. What is called what is that called? So they are different thing actually. Now we mostly deal about text. Now usually with the companies with which we work, for example, health data or financial data, they are made up of database tables and text. We usually don't create images, so that's a different area basically, which is out of scope for our course, and that demand is also very less because that is very small segment who are particularly interested in creating such models or creating images and things like that.
Yeah, that's what I'm talking about, the
Hmm.
design and the creative and all entertainment industry, right? There this
Right.
all runs into behind that one. So that's what I
Hmm.
was wondering, because the bigger part of the generative,
Hmm.
it's not only the text is
Hmm.
if human can read it, it's a
Hmm.
time consuming simplified, but
Hmm.
something visualize, making a dog and a different form, that is out of this human brain to conceptualize, right? That is the piece I
Hmm.
was trying to wonder how it's coming up. Okay.
So those models are basically called the diffusion models, right? So that's altogether a different stream, you know.
Okay.
And I mean, whatever projects I have done, they are mainly on this language only. And I mean, the industry is there. Okay, that media industry is there, but if you talk about the overall market, so that may not be more than 1 or 2%. I mean, this is my assumption, right? But yeah, I mean, definitely that segment is also
Yeah,
very.
yeah. I'm not
Mhm.
debating in terms of
No,
the
no,
market.
no.
I'm just questioning in terms of
Hmm.
if I had to visualize something like that's
Mm.
what I'm more curious.
Okay.
Having these things, definitely it's a part of
Mm.
the job, but the curiosity, the piece I was wondering about, okay, how really these things are
Hmm.
helping in
So,
terms of getting something
so
out
they
of
are
this, which
they
I
are
haven't visualized.
so they are
Yeah.
diffusion models, and they in the back end they use lot of inference power. That's why if you heard about when this Ghibli came out, right, lot of people were saying the images which you are sharing and the or generating, they actually cost a lot at the back end because they need lot of
Yes,
processing power.
GPU was
Mm.
melting down
GPUs,
there.
in fact, OpenAI CEO was saying our this is melting down, and our team is sitting in the office. They want to take some sleep and all because they need lot of processing because you are creating an image. So right now, if you
Yeah.
see, even a single image, it was taking 60 seconds or so. I also created a couple of images myself with Salman Khan and things like that. And the result was so impressive. Okay, let me show you, or let me stop the recording first.